Alright guys, so this video is about projectiles. So here we go. I'd first like to start by showing you a fun video from YouTube. Okay, I'm not sure if that's real, but let me tell you, I watched it over and over and over, just trying to figure out if it was real or not. I've been told it's not, but I'm just going to believe it was because that was pretty crazy. It's pretty crazy. So that person was a projectile. That's what I want to share with you. Okay, a projectile is any object moving through space only acted on by gravity and air resistance. Here's a baby blue comic for you to read. Dude, it's so cute. I love it. Okay, so we're talking about nonlinear motion now, not in a straight line. Nonlinear motion has two components, horizontal and vertical. These are very important. They're important to understand why a projectile takes a curved path, and they're important for solving your math problems. So up at the top of the page, the diagram, you can see the horizontal motion, and down to the side on your left, going down, you can see the vertical component. All right, so things I want you to notice is the horizontal. If you look, the balls are evenly spaced, so it's moving at a constant velocity. And the reason it does this is because there's no force acting on it. And if you look at the vertical component, you will notice that the balls are actually moving with less distance and then covering more distance every second that they're in the motion. The reason they're doing this is because gravity is causing them to accelerate. So having the horizontal motion and vertical motion acting on a ball as it falls causes the ball to actually follow this curved path, and the curved path is known as a parabola. So first we're going to just focus on horizontal component for a second. So the only force acting on the ball as it moves horizontally would be air resistance, but we are going to say there is no air resistance just to make things a lot easier at this level. Okay, so there is no force acting on the cannonball once it leaves the cannon. So it continues to move because of inertia. Inertia is like its own desire to keep moving. Once it's in motion, it resists the change of motion. So since it's moving, it just wants to keep moving at that speed. And so it will. It will keep moving at that speed at constant velocity because there's no force causing it to speed up or slow down. So the motion that the horizontal component has is a constant velocity, which means it covers equal distances per equal time interval. Again, this is only true if there's no air resistance, and all of our problems will have no air resistance because that's where we're going to be at this level. Vertical component. Now the vertical component, gravity is acting, and gravity acts down. Gravity does not act side to side, so it doesn't affect horizontal motion. It only affects vertical motion because gravity acts down. That's important. Gravity causes all things, regardless of what their mass is, to fall at a rate of 9.8 meters per second squared. Again, this is if there is no air resistance, and we are going to say there's no air resistance. So as the ball is falling vertically, it is actually accelerating. All right, so here it's showing, again, the horizontal component, constant velocity, and the vertical component is accelerating, and it's accelerating because of gravity. But gravity does not affect the horizontal motion, so it keeps moving at a constant speed. So they like to say that horizontal motion and vertical motion do not affect each other, and they don't, and the main reason why is because gravity acts downward. It does not act side to side. All right, so again, because of the horizontal motion and the vertical motion, the object will actually end up taking the curved path, or the parabola. Here you can see two things happening. You see your vectors, and your vectors are representing your vertical velocity and your horizontal velocity, or component if you like. So you'll notice with the vertical velocity or vertical component, as the object is moving upward, its speed is decreasing by 9.8. And the reason why is because the ball is going up against gravity, so gravity is causing it to slow down. At the top of its path, the vertical component or vertical velocity is 0. However, gravity does not affect the horizontal component. If you notice, the horizontal component stays 12 meters per second even at the top of its path. And then as the object starts to fall down, horizontal component stays the same, 12 meters per second. But the object starts to accelerate because it's going in the same direction as gravity. All right, so here we want to talk about which would hit the ground first. So if I took two objects and I threw one horizontally and I dropped one just straight down, just dropped it from rest, which one would hit the ground first? This is important. So this is a connection between horizontal and vertical component that you can use, and I'm going to show you a video that demonstrates what actually would happen if you threw a object horizontally and dropped an object from rest, both from the same height.
Here's a little device here that will shoot a projectile. A little spring here. I'm going to compress the spring. And when I do that, I can put a projectile here and watch this gang. A little spring gun. Out it goes. No surprise. But I've got another ball that I can put on the end here like this. And when I go like this, it falls essentially straight down. A little bit out, okay? But kind of downish. This one goes outish. Now I'm going to do them both at the same time. When I do them both at the same time, you guys got to figure out, hey, which one going to hit the ground first? The one that just dropped down or the one that goes out? A lot of people think, oh, the one that's fired out is going to be in the air for a longer time. You know why? Because gravity going to start to pull it and say, oh, I didn't know you were moving, go ahead. And gravity not going to pull so hard. What do you guys think? Let's try it. I tell you what. If you hear this, all A's. All for this course, all A's. Registrar say, Hewitt, my God, Hewitt, you got all A's in your class. I'll say, I had a sharp class, honey. I had a sharp class, all right? All A's. But if you hear this, then you got to do your homework, okay? Here we go, gang. Here we go. This next moment may be very important for a lot of you who have everything riding in your grade. All right, here we go. Here we go. Listen. What'd you hear? How many heard this? Wishful thinking. We'll do it one more time in slow motion. All right? Now you can get a better look this time. Slow motion. Here we go. Same time, gang? Yeah. Gravity doesn't take a holiday on an object just because it's moving.
Okay, so I really like that video because it shows that it doesn't matter as long as the objects are being thrown horizontally and dropped from the same height, they'll hit the ground at the same time. Now the reason they hit the ground at the same time is because what's causing them to hit the ground is gravity. And gravity is going to cause both of them to accelerate downward at the same rate. So it's gravity that causes them to hit the ground. All right? All right, so here's another one. What would happen if you aimed at the monkey and shot the gun when the monkey was let go? Would you hit the monkey? So here's another video for you. Or it's a little screenshot, actually. Maybe. There we go. So if you watch it, it'll play it over again. So the cannon is actually being shot at the monkey. So when the banana is shot and the monkey is released at the same time, but the cannon is being pointed at the monkey. and the monkey is being released at the same time because gravity acts on them the same, causing them to accelerate at the same rate, the banana will actually hit the monkey. Okay, let's go on. All right. What if I take the projectile and I throw it with a greater initial velocity horizontally? I'm going to throw it horizontally with a greater speed. Would it hit the ground sooner than if I dropped the object? Okay, so if I take the ball and I throw it harder horizontally, so it leaves my hand with a greater speed, will it hit the ground sooner than throwing it with less speed? Okay, will it hit the ground sooner? Okay, so now I'm going to bring up this app here and we're going to play with this. Maybe, there we go. Okay, so first what I'm going to do is I'm going to give my cannon a little bit of height here, and I'm going to turn him so he's horizontal, and I'm actually going to come over here and change the angle so it's 0. And I'm going to go ahead and I'm going to change the speed, let's do 5s to 5. Okay, so this 5 meters per second is the speed at which the ball is going to leave the cannon. All right. So I'm looking at two things. I want to see if the time changes, how long it takes to hit the ground. And we're going to look at also at the range. What happens to the range? Like, range is how far it goes out. So check it out. Here we go. All right. So it took 1.8 seconds to hit the ground. And how far out it went horizontally was 8.9. So what happens if I double the initial speed? So I'm going to make it 10. All right. And what I want to know is, first of all, does it change the time it takes to hit the ground? And then I also want to look at the range. Does the range change, like how far it goes out? So we'll fire. So I fired. Okay, so what I really want you to notice is just by throwing a projectile with a greater speed does not affect how long it takes to hit the ground, as long as we kept the height the same. Okay? So throwing it harder, the only thing that changes when you throw a projectile harder horizontally is it affects how far out it goes. It will actually travel farther. Okay? So it takes the same amount of time to fall to the ground, because what that depends on is gravity. And gravity causing the object to accelerate at 9.8 meters per second squared. All right, moving on. Hopefully you like that. Okay, equations that you guys are going to need to know. When you're solving for the horizontal component, your distance is the range, and you will use the equation t times v. And when you're solving for the horizontal velocity, you will use v equals d divided by t. Then when you're solving for the vertical components, to solve for height, you're going to use d equals 1/2 gt squared. And when you're solving for the vertical velocity, you are going to use v equals g times t. Now, going back to trig that we used before with the vectors, to solve any 90-degree angles that you might get, you're going to want to use math for this, Pythagorean's theorem. So you can do SOHCAHTOA, or some old horse caught another horse taking oats again. And then on the right-hand side at the bottom, if you need to solve for the angle, for example, you need to solve for the angle, mathematically, you go cosine angle equals, and then cosine is adjacent over hypotenuse. So then you'd go cosine angle equals, and then 4/5, and you're going to get those numbers off of your diagram. So then to actually solve for the angle, you're going to go cosine inverse times 4/5, which would equal 36.9 degrees. And I want you to try this on your calculator so you know how your calculator works so you can get the right answer. Some calculators you have to put things in a different order, and you might get the wrong answer. Okay, one other thing I want to talk about is hang time. So in the first diagram, what we're doing is we're just shooting the projectile from some height in the air. So when it falls, it's only going to form half of a parabola. In this case, the time that it takes for the object to hit the ground can also be used for the time that you use to solve any of your horizontal component equations. The time would be equal. However, if you look at the diagram at the right, in this case, your vertical time is actually half of what your horizontal time is, because you have both pieces of the parabola, because you're throwing it up and then it has to come back down. Okay, so we'll work on that in class. But just so you know, the hang time, the time isn't for vertical component and horizontal component aren't always the same, especially when you're throwing the object up in the air and then it comes back down. All right, guys, that's it. I hope that helped. Thanks. Have a nice night. Figure out how to shut the video off, right?